Welcome to Exam Essentials. Today we are going to solve Edexcel Mathematics Statistics 1 May 2025 question paper. In question number 1, we can see we are given a discrete random variable x and the probability distribution for that variable has been given in the table. In part A, we see we have to find f3.5. We know the f function represents the commutative probability distribution of our variable. To find the value of that function, we have to sum up the probability of all the values up to the point mentioned. In our case we are told to find f3.5. To find f3.5, we have to sum all the probabilities that come before 3.5. We can see our variable can only take values 1, 2, 3, and 4. There is no 3.5 in our distribution. So what will we do is we will add up all the probabilities that come before 3.5. So we will add probabilities of 1, 2, and 3. We will add probability that our function equals 1, and probability that our function equals 2, and probability that our function equals 3. We'll add them up. We can see the probability that our function is 1 is 0.3, for 2 it's 0.2, and for 3 is 0.35. Which will be equal to 0.85, and this is our answer. So for part B, we see we have to find the probability that this inequality is true. So at first we will solve the inequality to find the range of value of x for which this probability is true. So let us first solve the inequality. We will make x the subject. So this will equal x is less than 2.5. So to solve this probability, we have to add the probability of 1 and 2 together. As we are finding the probability that x is less than 2.5, we have to add the probabilities of the values which are less than 2.5. In our case, the values are 1 and 2. 1 and 2 is less than 2.5. That's why we are adding the probability of 1 and 2 together to find the probability that x is less than 2.5. This will give us 0.3 and 0.2, and our answer is 0.5. For part C, we have to calculate the expected value of x. The expected value of x is kind of like the mean of our distribution. To find the expected value, we have to multiply each value with its probability, and we have to do this for every single value, and then we will add all the products. We will sum the product of each value and its corresponding probability. That's how we calculate the expected value of x. The expected value of x is kind of like the mean of the whole distribution. So we write ex equals to, we will take a value, let's say 1, and we will multiply the value with its corresponding probability, which is 0.3, and then we will do this for every single value. Then we do this for 3, and then we do this for 4. This will give us 2.35, and this is the expected value of x. For part D, we see we have to show that variance of x, the variance of our variable x, is equal to 1.1275. as we are asked to show that variance is equal to 1.1275. What we can do is we can separately calculate the value of variance and then compare it with the one given in the question. So to separately calculate it, we have to use the relationship e x square minus the square of e square, this the square of the square of ex, to find the value of variance. We already know the value of ex because we have calculated it in the previous step, in the previous question. We only have to find the value of ex square. To find the value of ex square, we have to just repeat the same process as we did with ex, but in this case the data values will be squared. So 1 will be 1 squared. The probability will not change. The respective probabilities will not change, but the data values will be squared. 2 will be 2 squared, 3 will be 3 squared, and 4 will be 4 squared. This will give us 6.65. So we will just substitute the values. So 6.65 square, 6.65, sorry, not square, 6.65 minus, we know the ex equals to 2.35, so 2.35 whole square. This will equal 1.1275. We can see the value given in the question is the same as we obtained from calculating. So we can say we have shown that variance equals to this value. In part E, we can see that we have to calculate variance of 5 minus 2x. Here we see in part E, we have to find the value of the variance, 5 minus 2x. What has happened here is the variable x has been transformed, has been changed by horizontal and vertical. So for part E, we have to find the variance of 5 minus 2x. We know that adding and subtracting to the random variable x does not affect the variance of it. What affects the variance is the multiplied value. In our case, the multiplied value is minus 2. So the relationship between our variable x and any number multiplied to it is that this will be squared. So the variance of 5 minus 2x will equal minus 2 square into variance of x. This is true for any other transformation. For example, if we have to calculate variance of 5x, we will square 5 and multiply variance of x with it. If we have to find variance of minus 3x, we have to square minus 3 and then multiply variance of x to find it. This is the relationship. Whatever is multiplied to our variable x will be squared and can be multiplied to variance of x to find the variance of 5x. This will equal 4 into the variance of x, which is 1.1275. This will be equal to 4.51. And this is our answer. So this concludes our question number 1. We can move on to question number 2 now. In question 2, we can see that there are students in class A and class B who sit for a test. There are 24 students in class A and 30 in class B. The marks are given in the table. From the table, we can see that n is given. N is the size of the data set. In our case, the number of students. And x bar is given. From here, we can see that the marks is denoted by x. So x bar is basically means the average mark of the class. So we can, from the table, we know the average marks of each class is given. Here we have the summation of x square. What this means is that every single marks of that class is squared and then summed up to find this term. So when we when we see this number, we know that this is just the numbers, each single numbers of this class of the class squared and summed up together. Let us move to the questions. The two classes the two classes are combined into one group of 54 students. The two classes are combined into one group of 54 students. So the both classes are now combined. So their marks will also be combined when we have to find the mean, and when we have to find the standard deviation, and when we have to find the mean of the squares. Whatever we do, we have to combine all of this. So it is given that the mean mark for all the 54 students is 45. So the mean mark for all the 54 students, both classes combined, is 45. We now have to show that b equals to 4.3. So when we have to calculate b, we have to understand that we somehow has to relate and find the relationship that includes b in there. So how can so what can we use to write a equation in b? We can use the mean. We can see it is given that the mean mark for all 54 students is 4.5, is 45. Sorry. So if we write an equation keeping this in mind, for example, let's say I find the equation for the mean of the whole class. So what will this be equal to? We know the mean equals to 45, and the mean will equal to the sum will be equal to the sum of all the marks divided by the total number of students. So our denominator will be 54. What will be the numerator? What will be the total marks? The total marks in each class will equal the number of students and the average marks. This will give us the sum of the sum. This will give us the sum of marks. This will give us the sum of marks in each class. Multiplying the number of students and the average mark will give us the sum of marks. So this is exactly what we will do. To find the sum of marks for the whole combined group, we'll first add the sum of marks from A, which is 24 into 47, and then we will add the sum of marks for B, which is 30 into B. We can see this equation gives us one unknown, that is b, and every other number is known. So we can just rearrange the equation to find b. So that is what we will do. We can simplify, further, or we can just write it directly. This will be equal to 43.4, and this is our answer. For B, we have to find, for part B, we have to find the standard deviation for the whole combined group. To find the standard deviation for the combined group, we have to find the sum of. We have to find. We know that first of all, we know that standard deviation equals the mean of squares and the square of mean. We already know the mean of the for the whole combined group. So we just have to calculate. We just have to calculate the mean for x squared. To find the mean for when x or when it's x squared, we can just find out the sum of x squared for the whole group. To find the sum of x squared for the whole group, we just have to add the individual sums together. We can see here the sum of x squared terms is this for A and this for B. We can just add them together to find the combined sum for the group of 54. So we can write, this will equal sum of x square from A and sum of x square from B, which are equal to 73826. Minor correction 66 and 876. This will equal this is our sum of x square. So to calculate standard deviation, we have to root the mean of the squares, and we have to subtract the square of the mean. We know we already know the sum of x square, so we can just substitute each value at the particular place in the formula. So n here equals to 54, and minus we already know the mean for the whole combined group, which is 45. So 45 squared, and we will root the whole thing to find the standard deviation. If we calculate this, we find uh, if we calculate this we find the value is 24. What this means is that each value what this means is that the average difference between each value of marks and the mean value of marks is 24.095. If we move on to next question, which is C. Following moderation, each student in class B has their marks increased by 2. So the marks of each student in class B is increased by 2. Our question for part C is, without further calculations, state, giving a reason in each case, the effect this will have on the variance of the marks for class B. We know the variance is not affected by adding and subtracting. It is only affected when our variable is multiplied by something. When a variable or our data is multiplied by something. It's multiplied by some factor or divided by some factor. It is not affected when we add something or subtract something. So our variance will be the same as before. So we can write no effect. We can write it will have no effect because adding will not change the value of variance. For number 2, our question is the mean mark. We know that mean is affected by, unlike variance, the mean is affected by adding and subtracting. So if each mark is increased by 2, the mean will also increase. We can say the mean will increase because total marks has increased. For 3, we can see the standard deviation of the marks for all 54 students. Now we are asked about the standard deviation of the marks for all 54 students, not just class B or class A, for all 54 students. As the mean of class B has changed and the mean of class A has not changed, the standard deviation will change. The standard deviation will change. The standard deviation, to be specific, will decrease. Because as the mean of uh, our B, the mean of B is increasing. As the mean of class B is increasing, the mean is getting closer and closer to class A. So their variance, so the standard deviation of each of the value of each of the marks will decrease. So we write, because the mean as the mean of B is closer to the mean of A, the deviation, the difference between each term and their mean will be less, will be more, the difference will be more smaller. That's why the standard deviation will decrease. So this concludes our second question. We can now move to the third question. Here we have question number 3. It says, statistical models are cheap and quick way to make predictions about real world situations. Give one other reason why statistical models are used. So we can say to analyze, improve, and have a better understanding of our model or our data. For part B, we are given additional information. Madison wants to develop a model to describe the relationship between average daily temperature T, the average daily temperature T, and a household's daily gas consumption D meter cube in winter. So the two variables that we are discussing here is T for temperature and D for gas consumption. Madison takes a random sample of 12 days. So n here, the total number of data is 12. And she quotes the daily gas consumption as W equals to 1.5 D. So some summary of the data is given to us. We have to show that as WW is equal to 445.57. How will we show this? For part B, we have to find as W and W. How will we find this? As W and W, the way to find this is to use the sum of W square and subtract the square, the mean of the square of the sum. We know that if there are two variables, if we have to find the summary statistics of two vari- of the same of the same variables, we use sum of x square minus sum of x whole square divided by n. There is another version of the summary statistics we need, which is that when there are two variables, let's say x and y, then what we use is the sum of the product of x and y. Then we subtract sum of x into sum of y divided by n. These are the two formulas we need. In our case, we need to find as w and w. As there are two variables of the same, as the two variables are the same, we will use the sum of w square and subtract from it the sum of w whole square divided by n. Now what is left to do is just substitute the values in. We know sum of w square is this and sum of w is this. We'll use these values. So sum of w, we will use the information from above, 10,036.45. So it is 10,036.45 minus the sum of w, which is 339.25, 339.25 whole square divided by 12. This will give us the summary statistics for w and w. So this will give us from the calculator 445.57. So this is the answer to part B. For part C, we are asked to find the value of STD and SDD. We have to find the value of STD and SDD. One thing to notice here is that the summary statistics we are told to calculate here is not the value, cannot be calculated directly, because we know for this For this particular calculation, we need the sum of t and d minus the sum of t into the sum of d and divided by n. If we use this, we cannot directly find the value of summary statistics of t and d, because we don't directly know the values of t and tt or t or sum of d, because they're coded in. We need to find them and then substitute them. Or there is a better way. The better way is to use the relationship between the summary statistics of STW and STD. As the data are coded, there is a certain relationship between the summary statistics of STD and STW. We know that when data is coded and the data coded, let's say here the data is coded from X to W. In this scenario, let's say the data coding is this. In this scenario, what we have to do is we have to multiply. We have to take 2 and square it to find the relationship, to form the relationship between as the coded and the non-coded data. If there is only one variable that is coded, let's say as xy and wt, then we have to only convert one single variable to non-coded value. So we will take the factor that is multiplied, which is 2, and we'll multiply it without squaring the term. We'll use this fact here. Here we see that when we are converting t and d to t and w, we are only decoding one single variable, which is w. We're converting t. We're converting d into w. So what we have to do here is we have to divide by the factor that was multiplied to get w. We know that w is equal to 1.5d. So d equals to, we know that w equals to 11.5d, and d equals to 11.5 divided by, sorry, d equals to w by 11.5. Now to convert w from here to here, we have to divide stw by 11.5. Now this is the relationship between std and stw. Now if we calculate stw, we can just divide by 11.5 to find std. So let me use the values from the question. We know that stw is equal to minus 91.55. So we can write minus 91.55 divided by 11.5. This will give us a value of minus 7.96 after rounding. In this same question, we are also asked to find SDD. Now, to find SDD, we have to use SW and W. Now, we can see here that two variables, two of the same variables are decoded here. Two of the same variables are decoded here. That's why we have to use the decode. We have to, when dividing by the decoding factor, let's say 11.5, we have to square it because two variables are decoded. So we can use the value of SWW and divide it by 11.5 whole square to find the value of SDD. We'll use the value from the question. We already know the value of SWW because we have calculated it in part B. The value is 445.57 divided by 11.5 whole square. This will equal this will be equal to 3.3691, which can be written as 3.37. This concludes our part C. For part D, we see we have to find the product moment correlation coefficient between D and T. The product moment correlation coefficient, which is R, can be calculated by this formula. As the data is just coded values and the data is coded linearly, as the data is coded linearly, we can just find the product moment correlation with the coded values. We do not need to find the values with the decoded value. We can just use the coded values. So we can use the formula of where STW divided by root over STT into SWW gives us the coefficient. We will just use the value as given in the question. This is 91.55 divided by root over of STT into SWW. STT is given as 26.43 into SWW, which will be equal to 445.57. If we find the coefficient, it will be equal to 0.844. This is our answer to part D. Let's move on. For part E, we are asked give an interpretation in context of your product moment correlation coefficient. The first thing to see is that our product moment correlation is negative. It is negative, which means that there is a negative correlation between our two variables. Our two variables are temperature and gas production, D. So we can write that as temperature increases, the gas consumption decreases. Because why can we write this? Because there is a negative correlation. The correlation coefficient is negative. That's why there is a negative correlation between them. So as one variable increases, the other variable will decrease. Now if we see part F, we have to show the equation of the regression line of W on T. From here we can see that T is the independent variable here. So we can find the gradient. So to find the line, so to find the equation of the line, we have to find the gradient of the line. The line is the line of the line is in this format. The line is in this format, where b is our gradient, where b is our gradient, and this gradient is equal to, and this gradient is equal to our STW divided by our STT. As t is independent, the gradient will be calculated by STD, the summary series of STD, and divided by STT. This will give us the gradient for this regression line. Now, now for A. Now to find A, we have to find the means. We have to find the mean of T and W. We have to find the mean of T and W, and use the mean in the equation to find the value of A. So if we find the gradient, before, so we have to find the gradient before. To find the gradient, we just input the values in the correct places. So STD is equal to STD is equal to minus 7. I'm sorry, we'll be using STW. We'll be using STW because we are forming the line between T and W. So we will use STW divided by STT. So STW is 91.55 and STT is equal to 26.4543. This will give us a gradient of minus 3.4638, which is equal to, we can just keep this value as it is because we're going to use it again to form the equation. As we now know the gradient, we can find the mean of T and W to use it to find A. If our equation is like this, we can find A by making A the subject of our formula. So if we input T and W, if we input the average of T and W, our equation looks like this. Now if we input the average of W and the average of T in the equation and also the gradient, we can find A. The average of W will be calculated like this, and the average of T will be calculated like this. And the average will be given by 339.25 and 9.1. So it is 339.25 divided by 12 plus 3.4638 into 9.1 divided by 12. This will give us A. So A is equal to, so A is equal to 30.9. Now now we can just form the equation W equals equal to 30.9 plus, sorry, minus of 3.4638 T. Now we can see the question. We can see the question, and we see that the values of intercept and the gradient are given to three significant figures. We have to give the values to three significant figures. So we have to. So we can write that we can write that 30.9 plus 3.4 plus 3.464 into T. So this is our regression line. Now for the next part, we have to write down the equation of regression line of D on T. For the next part, we have to write the equation of D and T. We know that W is the coding of D. We from part D, from part F we know that W equals to 30.9 minus 3.46 T. So we can, and we also know that W equals to 1.5 D. We can just substitute this in. Now, if we make D the subject of the formula, we have to divide every coefficient with 11.5. This will give us minus 0.301 and 2.69, and 0.301 for these values. This is our answer. In part G, we had the equation D equals to 26.9. We have the equation G equals to 26.9 plus, sorry, minus 0.301 T. We had this equation. Now for part H, we have to estimate. For part H, we have to estimate the daily gas consumption, which is D, when temperature is 2. So we will use this equation, and we will input 2 in place of T. This will give us the daily gas consumption. This is the daily gas consumption for this. For 2, we have to interpret the effect. An increase of 1 degree Celsius in an average daily temperature is expected to have on the daily gas consumption in winter. What this refers to is the gradient of the function. the gradient of the function, which is 0. The gradient of the function, b, which is minus 0.301 t, gives us this value. It shows us that a daily increase of 1 degree Celsius of one increase. It shows us that increase in 1 degree Celsius will decrease the gas consumption by 0.301 meter cube. So we will just write this. The gas consumption will decrease by 0.3 meter cubes. This is the interpretation of this. The gradient of the function shows us that if the temperature increases by 1 degree Celsius, the daily gas consumption decreases by 0.30 meter cube. So that is what we have written. So this was the question 3. This was question 3. We can now move to question number 4. For question number 4, we see there are two events, C and D, and the probabilities related to them are also given. This is the probability of C union D, this is the probability of D, and this is the probability of C given D. In part A, we are asked to find the probability of C intersection D. To find this, we can use this relation. We know from the question that probability of C given D is equals to 0.2. Now probability of C given D can be written as probability of C intersection D. This is the way of calculating conditional probabilities. We know to calculate conditional probabilities, we need to use the probability of intersection, the probability of intersection of the two sets divided by the intersection of the given set, divided by the probability of the given set. So we'll do the same thing here. Our conditional probability will equal the probability of C intersection D divided by the probability of D. This will equal 0.2. From the question we already know the probability of D, which is 0.45. So we will substitute this inside. This will be 0.45. From this we know that C intersection D will equal 0.2 into 0.45, which is 0.09. This is the probability as required in our question. For part B, we have to calculate a probability of C. Probability of C. We can see it is given that the intersection of C with D is 0.59. We already see from here that the union of C and D is given as 0.59. So to find P and C, we can say that C union D is equal to PC and P probability of D minus probability of C intersection D. Now P probability of C is unknown and probability D is known as 0.45 minus, and the probability of C intersection D is what we calculated. This is 0.09. We also know the union of C and D, which is 0.59. We will make the probability of C the subject. This will give us 0.23, which is the answer of this question. So this concludes our question number 4. So here is our question number 5. The following group frequency distribution summarizes the speeds in kilometer per hour that a random sample of 225 cars were doing on a road. So the frequency table is given. We have a certain class and the frequency of that class is given. Next, it is said a histogram is drawn to represent this data. The height of the tallest bar is 10 centimeter. So the height of the tallest bar is given. We know in a histogram the y-axis or the y-axis or the vertical axis represents the frequency density. So if we can find the frequency density of each class, we can compare the frequency density to find out which bar is the highest, which bar is the tallest, and which bar is the second tallest or the third tallest, and so on. By the way, we can see that in part A, we have to find the height of the second tallest bar. So at first we can find the frequency density of each class. From here we can see the class width of the first class will be 5. The frequency density, the class width of the first class will be 25 minus 20, which will be equal to 5. For the next class, we can see the class width will be 25, 20, 30 minus 25, which is equal to 5. For the third class, we can see that the class width will be 40 minus 30, which is 10. For the next class, we see the class width is 55 minus 40, which is 15. And for the last one, it is 70 minus 55, which is 15. We can use this information to find the frequency density. Before finding the frequency density, we will write the formula. Frequency density is equal to K. K is the assumed value. It determines the scale of our histogram. So frequency density equals to K into frequency divided by class width. We can assume that K equals to 1. So now we can find the frequency density of each individual classes. For the first class, the frequency is 54 and the class width is 5. The frequency density is 10.8. So frequency density is 10.8. For the next one, the frequency is 90 and the class width is 5. This gives us an 18, which is the frequency density of our second class. For our third class, we have a frequency density of 60 divided by the class width of 10. This gives us 6. So this is 6. In the same way, if we calculate for the last two classes, we find that the frequency density of this is 1 and the frequency density of the last one is 0.4. As we have calculated the frequency density, we can just see and choose the the class with the largest frequency density as the tallest one. So this is the tallest one. It has the highest frequency density. So this is the tallest one. Our second tallest one is this one. We know the height of the tallest bar is 10 centimeter. meaning that the tallest bar, which is 18 centimeter, which is 18 units, is represented by 10. So we can form a ratio of 10 by 18, and we can equate this ratio with the ratio of the second tallest bar. We have assumed the value of the height of the second tallest bar is x, and we have formed a ratio of x and 10.8, and we have equated it with the height and the frequency density of our tallest bar. This gives us this gives us 6 as the height. So the answer to our part A is 6. For part B, we have to estimate how many of the 225 cars were doing a speed between 35 and 57. We have to show that we have to estimate the number of cars that were doing a speed between 35 and 57. So the number of cars doing 35 to 57 will include the classes number 3, 4, and 5. We have to estimate the class width, and then we have to use our frequency density to find the frequency, to estimate the frequency within that new class width. So we can write for part B, for part for part B, number of cars with the speed between with a speed between 35 and 57 is the class width of 35 to 40, which is 5, into the frequency density, which is 6. What will we do is we will take 35 to 40, we will take the class width of 35 to 40, which is 5, and we will multiply 5 with the frequency density, which is 6. Then we have to add the frequency of this whole class. We have to add the frequency of this whole class, because this whole class is included within our required class. So we have to add the frequency of the whole class, which is 15. Next, we have to estimate from the class width the frequency of the smaller range of the smaller class within the bigger class. So our new class will be 57 to 55 to 57. The class width will be 2, and we'll use this class width, and we'll use its frequency density to find its frequency. This will give us the total frequency. This expression will give us the total frequency. So we can calculate it now. This gives us 45.8, which is 46 cars. Writing 46 rounding up is necessary, as the number of cars cannot be in fractions. or in decimals. In part C, in part C, we are asked to use linear interpolation to estimate the median speed in kilometer per hour for the 225 cars. To find the median speed, we have first have to recognize the class in which the median lies. The class in which the median lies is the class in which the median lies is this class. So we will use this class to find the median. We can write the upper end is 30 and the lower end is 25. And the number and then the frequencies for it is 90 and 45. We can write the values above, and the frequency for 25 is 54 and for 90 is 144. Our median will be our median will be at 225 divided by 2, 102.5, fifth position. We can represent this on the line we have drawn. This will be 112.5, and the value is x. The value is quarter 2 that the value is quarter 2 that we need to find. So now we can find the ratio. We can use the ratio. Now we can write the ratio of Q2 minus 25 divided by 30 minus 25. Then we can write the corresponding ratio for the positions. For the frequency, we can write 112.5 minus 54 divided by 144 minus 54. We can simplify this. Now to find our median, we will write we get 28.25, which is 28.3. This kilometer per hour. Now to find the upper quartile, we have to find the upper quartile. We we'll use the same technique of linear interpolation. First of all, we have to find out in which class our upper quartile lies. For that, we have to find the position of upper quartile, the frequency at which the upper quartile occurs. So we can write this is 168.75. This is the data in which the upper quartile occurs. So now we have to recognize the class in which this value lies, this data lies. So we can check by adding the frequencies. We see that our value lies in this class. Now we can do linear interpolation to find the value of upper quartile. So this is 30 and this is 40, and the values for them are the values are 30 and 40. Okay, we can just write them above, and the frequency for them will be 90, for them will be 144 and 204 and 4. If we write the cumulative frequencies, if we find the cumulative frequencies of this graph, it becomes easier for us to find out in which quadrant, in which classes, uh, our median, our mode, our upper quartiles lie. If we find the cumulative here, we can see this is 54 and this is 144 and this is 204, this is 290 and this is 225. So from this we can see that 168.75 lies in this class, which is 30, which is x is greater than 30 but less than 40. So let us do the linear interpolation. We can mark that 168.75 lies somewhere here, and the value for them for that is unknown. Let me mark it with quarter 3. So we can just write now that quarter 3 minus 30 divided by 40 minus 30 will equal 204, will equal 168.75 minus 144 divided by, we can write 168.75 minus 144 divided by 204 minus 144. Now we can simplify this. Quarter 3 by 10 will equal 168.75 minus 144 and 204 minus 144. This will be equal to 33 by 80. So quarter 3 will equal 30 plus 33 into 10 divided by 80. Now this 3.125, which can be written as 3.13. So this one D1. This was D1. For part 2, we have to find the interquartile range. We know the interquartile range IQR equals to quarter 3 minus quarter 1. We know the quarter 3 is equal to 3.13, and we know that the lower quartile, which is, I'm sorry, but the third the quartile 3 is equal to 34.1, 34.125, which is then equal to 34.13. So as I was saying that for our interquartile range, we have to subtract q1 from q3. Q3 is equal to 34.13, and q1 is given in the question. Q1 is given as 25.14. So 25.14. This gives us the interquartile range of 8.99. This gives us the interquartile range of 8.99. For part E, we can see it says describe giving a reason, the skewness of the data. For this, we can see we can compare the closeness of our quarter 1 to quarter 2 and quarter 3. If we calculate quarter 2 minus quarter 1, that the closeness of quarter 1 to quarter 2, we find that 28 minus 3 and 25.14 will equal 0.3 minus 25.14 will equal 3.16. And we already know that quarter 3 minus quarter 1 that we calculated before is 8.99. Thus we see that our quarter 1, our median value is closer to quartile 1 than quartile 3. So we can say that the data is positively skewed. We can say that quarter 2 minus quarter 1 is less than quarter 3, or upper quartile minus lower quartile. Thus we can say the data is positively skewed. This is our answer to part E. For part F, we read Ali suggests that a normal distribution is suitable model for the speed that cars were doing on this road. With reference to your answer in part E, comment on Ali's suggestion, giving a reason for your answer. For part F, we can write that it is not suitable. The reason it is not suitable is because a normal distribution is symmetric. The distribution is symmetric on both sides. But here what we see is that the graph is skewed. It is positively skewed, so it is not symmetrical. That's why Modeling the speed with normal distribution is not suitable. And this goes F. So this concludes our question number 5. We can now move to question number 6.
Let me guess. You are watching videos, taking notes, maybe even grinding late at night. But the marks, they are just not going up. You are stuck, and it's frustrating. But here is the truth, it's not your fault, it's the method. And that's exactly where Exam Essentials makes the difference. We at Exam Essentials actually offer two very powerful courses to navigate you towards success. The first one is the most popular high impact crash course. If you are just 4 to 6 months away from your exam, this course is going to be a lifesaver for you. And the second course that we at Exam Essentials actually offer is the complete 1 year course. This is basically for the students who want full support from day one to exam day. And the best part, our students' results speak for themselves. Both the courses are actually open ahead of every exam session. No matter whether you are going to give your exam for the May 26, Jan 27, May 25, or October 25, doesn't matter. We always offer these two courses before every upcoming exam session. To join or know more, just check the description box below. You will find our WhatsApp number and Facebook page link right there. Let's turn your effort into results together.
So this is question number 6. Here we see a company produces small bags of flowers and large bag of flour. The weight x gram of flour in small bag is normally distributed. So the weight is distributed normally with and the normal distribution has a mean. The weight has a mean of 502 and a standard deviation of 3. One of the small bags of flour is selected at random. In A1, we have to find the probability that x, the weight of the small bag, is greater than 508. To find the probability, of this bag of flour being greater than 508 gram, we have to convert this value to a standard value. To convert this value, we have to take the value and we have to subtract the mean and then divide by the standard deviation. This will give us a standard value of 2. The probability, now we can just look at the data table and find the value for which z is greater than 2. This will be equal to 0.028228. For A2, we see we have to find hence. It is said that hence find probability that x is greater than 496 and less than 508. We can see the question uses hence. This means that we have to somehow use the part 1 to find part 2. We have to keep this in mind because the marks will be deducted if we use any other method. At first, what we can do is we can convert these into standard values. So what we can do is subtract the mean from them, and then divide by standard deviation. Again, we can also do this for this also. So we can subtract the mean and divide by standard deviation. This will give us a minus 2 and a plus 2. We can see that we can see that we can see that the region that is required from us is this, as highlighted. To find the probability of this region, we have to we have to take the probability of x less than 2 and subtract the probability of x less than minus 2. We can see that if we take the standard deviation, we can see that probability where x equals to x is less than 2 represents the represents gives us the probability of the whole function before 2. It gives us area. And then if we separate x equals to minus 2, this area from it, it gives us our required area. That is what is given here. Now now we can write this probability like this: 1 minus the probability of x is greater than 2. And we can write this probability as probability of x greater than 2. We have previously shown that the probability that x is less than 2 minus 2 equals this region. This region is exactly numerically the same as this region, which is probability of x greater than 2. These are exactly the same region. That's why we can replace probability of x less than 2 with probability of x greater than 2. So we can simplify, and we already know the value of this. So it will be the answer to this will be 0.9544. Now for part B, it says a random sample of four small bags of flour is taken. Find the probability that exactly two of these small bags each contain more than 508 grams of flour. To calculate this, we have to multiply the probability of x being greater than 500 by 8 with the probability of x being greater than 508 and the probability of x being less than 508 and the probability of x being less than 508. As there are two bags who have the weight which is greater than 508, we are multiplying these two times. And as there are two bags whose weight is less than 508, we are multiplying this term two times. So we can write the probability of x is greater than 508 from part A, which is 0.0228, and as we are multiplying it two times, we can square it. Next, we can multiply the probability of x less than 508 and square it. So the probability that x is less than 508 is 1 minus 0.0228 whole square. This gives us the probability for one of the combinations. There are six possible combinations for this. So we have to multiply the probability with 6. This will give us 0.002978 from our calculator. This is rounded to 4 decimal places. We can see the four combinations here. So there will be two more than 508 and two less than 508. This is a single combination. Another combination is this. Another one is this. Another one is this. Another one is this. And the last one is this. These are the six combinations possible. So this concludes our part B. For part C, we see the weight y grams of flour in a large bag is normally distributed with a mean of 1024 and the standard deviation of sigma. The 85th percentile for the weight of the flour in a large bag is given to two decimal places. Show that our standard deviation is 14. So we can form an equation. So we can form the equation by using the information given and then find the standard deviation from it. So what we see here for part C, what we see here that for at part C, what we see is that the information given can be written as y is y being less than 138.51. 51 gives us a probability of 0.85. It can be represented like this in the distribution. A value here gives us the total probability. The area of the graph is 0.85. What we can do is we can convert this into standard value. So we can write y less than 1038.51 minus the mean, which is 1024, divided by our standard deviation, which is sigma. This will give 0.85. So upon further simplification, we see z is less than 14 by 0.51 by sigma. This will equal 0.85. From our data table, we know that the z value for which the probability is 0.85 is 1.0364. We can equal our value with it. This will give us a standard deviation of 14.51 divided by 1.0364, which will be equal to 13.999 from our calculator, and this is equal to 14.0 grams to the nearest gram. Now for part D, we can see it is given that the probability of x being greater than k is equal to the probability of y being less than k, of y being less than 2k. Now our question is find the value of k. What we can what we can do is we can convert the value of k to a standard value. So probability x being greater than k can be written as probability x is greater than k minus 502 divided by the standard deviation, which is 3. This gives us the standard value. So we can write it in terms of z. For y being less than 2k, we can write the probability of y being less than 2k is 2k minus 1024 we can write 1024 minus 2k divided by 14. Now we can equate the two equations. Now now we know that now as all of these are in standard values, we know that as the probability of x being greater than k and y being less than 2k is the same, their standard values must also be the same. So we can equate the values. If we simplify, we get 28, and we get here is 30 into 30 in 72. This will give us the value of k as 505. For part D2, we have to find the value of p. We already know the value of k, so we can just substitute the value of k, and find the probability of that particular value. For part D2, for part D2, this is D1. For part D2, we have to find 505. So we can write the standard value is equal to 505 minus 502 divided by 3. So x is greater than 1. The probability of x being greater than 1 is 0. Is 0.1587 from data table. So this concludes the question number 6. We can now move to question number 7. Okay, this is question number 7. Riley has a bag containing 3 white beads and 6 yellow beads only. 2 beads are selected at random from the bag, one at a time without replacement. So the bag contains 3 white beads. The bag contains 3 white beads and 6 yellow beads. So the total number of beads in our bag is 3 plus 6, which equals 9. 2 beads are selected at random from the bag and without replacement. This means that the balls are not returned back to the bag. The balls are, not are separated from the bag. They are not returned back to the bag once chosen. This means that after every single turn, the number of beads will decrease by 1. The total number of beads will decrease by 1, and the number of the specific color that is chosen will also decrease by 1. So we can move the question parts. In part A, we are told to complete the T diagram. So this is the tree diagram for the probability. So we have to complete the whole tree diagram. Now, what is the probability of choosing white as the first bead? The total number of beads is 9 and the number of white beads is 3. So the probability of choosing white bead as the first bead is 3 by 9. Same the same we'll calculate the probability of yellow in the same way. The probability of calculating yellow as the first bead will be 6 out of 9 because there are 6 yellow beads and the total number of beads is yellow. The total number of beads is 9. So the probability of choosing yellow as the first bead will be 6 by 9. Now choosing white as the second bead. When choosing white as a second bead, we have to keep in mind that a white bead was already chosen. So the total number of beads will decrease by 1. Before it was 9. Now it will become 8. The total number of beads will become 8. And as a white bead was already chosen, the number of white beads will decrease from 3 to 2. For the probability of choosing a yellow bead as the second bead, we know the total number is now 8. As a white bead was chosen as the first bead, the number of yellow beads will not change and they will remain 6 in number. So the probability of choosing yellow as the second is 6 by 8. 6 being the number of yellow beads and 8 being the total number of beads. When yellow is chosen as the first bead, we see the total number of beads already decreased by 1 because the beads are not returned back to the back. The number of white beads did not change because a yellow bead was chosen as the first bead. So they will remain 3 in number. As a yellow bead was chosen as the first bead, when we are choosing another yellow bead in the second beads, we have to consider the number after, which is 5. This is the tree diagram for part A. We can move to part B. In part B, it says find the probability that exactly one of the beads is selected yellow. The key word here is exactly one, which means that out of the 2 beads chosen, there must be 1 yellow bead, not two yellow, but exactly 1. However it may be, but it needs to be 1. So let us see which probabilities we need to consider. We have to consider this probability, the probability of choosing a white as the first bead and the yellow as the second bead. Another combination that is eligible for this question is probability of choosing a yellow bead as the first bead and white bead as the second. Notice that for both of these probabilities there is exactly 1 yellow bead that is chosen. So to find the probability in B, we have to consider both of them. To be more specific, we have to add them up. So for part B, we can write probability of choosing exactly 1 yellow, exactly 1 yellow is equal to probability of choosing a yellow bead, or we can go chronologically, probability of choosing a white bead and then a yellow bead, and probability of choosing a yellow bead and then a white bead. These are the probabilities we need to sum up to find our desired probabilities. The probability of white then yellow is just the product of individual probabilities. So to find the probability of choosing a white bead and then a yellow bead is just 3 by 9 into 6 by 8. We can write it down. The probability of choosing a white then a yellow will be the probability of choosing the white as the first one and the probability of choosing the yellow as the second one, which is 6 by 8. And the probability of choosing a yellow and then a white will be the probability of choosing yellow as the first, which is 6 by 9, into the probability of choosing white as the second, which is 3 by 8. This will be equal to half, and this is our answer. For part C, if we read the question, it says find the probability that at least one of the beads is selected white. Again, the key word here is at least one of the difference between part B and part C is in part B the requirement was that exactly one of them has to be yellow. There cannot be two yellow because because we are asked to find only one yellow between the combinations. In part C, the condition is different. Here we have to find at least one of the beads. We find the probability that at least one of the beads is selected is white, meaning that there we can choose two whites because one of them is white, so it will be eligible. It will satisfy the condition that at least one of them is white. So the probabilities we need to consider for part C are the three probabilities that I will show here. For example, this is the probability that we will consider. This is another one we will consider, and this is another one we'll consider. Notice that these three probabilities have at least one white. This is what makes them eligible for our question. So to find the probability of at least one of the beads being white, we need to add the probability of both of the beads being white, the probability of one of them being white. Now there's many ways to calculate this probability. The easiest one straightforward way will be to just add all the probabilities together. Another way would be much easier way would be to subtract the probability of getting two yellow, to find the probability of getting at least one white. So we can write probability at least one white will equal 1 minus probability of getting two yellow. The probability of getting two yellow is 6 by 9 into 5 by 9. This is equal to 7 by 12. So basically what we did is there are four probabilities, and we have subtracted and we have subtracted and we've subtracted this probability from the sum of all of them, and thus this will give us the sum of the three probabilities that is required from us. For the next part D, we are asked to find the probability that both of the beads selected are white. A condition is given here. Given that at least one of the beads selected is white, find the probability that both of the beads selected are white. This is a conditional probability. To calculate this, we can write probability we can write required probability is equal to so now if we try to find the probability that was given in the question. So probability of choosing a red, then a yellow bead, and then a white bead is given in the question as 3 divided by 235. Now, if we try to calculate the probability using expressions which include n, we will write the probability of choosing a red bead as the first bead is the number of red bead, which is half n, divided by the total number of beads, which is n. The probability of choosing red as the second bead will be the number of red beads from before minus 1, because a red bead was already chosen, so the number of red beads will decrease by 1. As a bead was already chosen, the total number of beads will also decrease by 1. Next, we will multiply the probability of choosing a yellow bead, but as a third bead. The number of yellow beads will be equal to 1 by 8n, and the total number of beads will decrease 1 further, so it will be n minus 2. Next, we will multiply the probability of choosing a white one. So the number of beads will decrease by one more. This will become n minus 3, and the probability of the number of white beads is the same as before because a white bead has not been chosen yet. This equals 3 by 235. What is left to do is just simplification. What we can do here is we can simplify this equation by moving the denominators to the right side. This will look like this. We can simplify further. This is equal to 3 by 128 into n cube half n minus 1. This will be equal to 3 to 35 n minus 1 n minus 2 and n minus 3. So we can simplify it further. So after simplifying it further, we get n cubed. We can take half common from this factor, and we get 1 by 235 n n minus 1 n minus 2 n minus 3. We can see a number of things get cancelled out here. We can see n cube and n are free terms which can be cancelled out, not completely, but still. We can see the factor n minus 2 can be cancelled out. So we will do these simplifications. We can write 2 235 n cube will equal to 56, 128 from here, and 2 from this half is multiplied together to get 256, and we get the fractions n minus 1 and n minus 3. Sorry, a correction would be that this will be n square because we will already cancel out a single n from this n cubed because of the free n term. We can now expand the brackets. Further expansion. Further expansion will give us plus 7, 6, 8. We know there is an n square term here. We can move it there. We can move it to the right. So this will then equal 21 n square minus 1 for n and 7, 6, 8. The equation we get is what we are supposed to be showing. If you see the question, this is the equation we are supposed to show, and we have found the equation. What is left to do is compare and find the value of b and c. The value of b will be minus 1024, and the value of c would be 768. Next, this was the whole paper, and this was the solution to number 7.